Good afternoon, everyone. This is IPPM, IP Performance Metrics. Oh, no, it's not IP Performance Metrics anymore. We actually had a conversation about that about a year ago. Now it's IP Performance Measurement. It's actually correct on the slides. I'm Brian Trammell, co-chair, Tommy Polly. Are you going to comment on the name, Matt?
Yes. No.
Thank you, sir. If you intend to be an IPPM, you're in the right place. If you don't intend to be an IPPM, you're going to learn some stuff today. So I'm Brian Trammell, Tom Polly, co-chair. Bill Cervani could not be here with us. This is an IETF working group meeting. Everything you say here can and will be used as a IETF contribution. If you don't know what that means, have a look at the documents here. Next, we have an agenda. It's extremely full. I don't think we're going to get to all of the things on our lightning talk queue. We're going to look at the status on some of the documents that are heading out. We're going to talk a little bit about next steps for IOM. Then some updates on these are the ITU liaisons, I guess. Al will keep us up to date on how he's been talking to himself, I think. Because you're both sides of that liaison relationship, right, Al? No. Okay. Oh. I'm just the communications chair. Okay. Cool. Excellent. Talk about advanced route metrics, the multi-point alt mark. Then we'll go into the IOM content section of today's agenda. We have a few individual drafts that have had list discussions, so we're going to go ahead and give them time on the agenda as well. So stamp option TLV has actually had quite a lot of discussion and is basically ready. Is it adopted? I thought it was ready. The call for adoption is, oh yeah, no, right. We had to figure out that, yeah, exactly, right. Spring PMAP SRPM, and then the postcard telemetry stuff, which I understand there was also some hackathon activity on the postcard telemetry as well. Then we have our lightning talk queue. As I said, there are more here than will fit, but if we go fast, then we will get to all of them. And if we don't go fast, then we will not. Our apologies to those at the end of this queue. So let's talk about status updates. We published 8545. We sent the registry drafts to the IESG. It actually turns out that there was a miscommunication on that one. I'm the shepherd for one of them, and the shepherd statement is incomplete. We send it to the IESG anyway, but I will fix that this week. But those should go through relatively quickly. And it was cool. I copied these slides from the last time that we had a meeting, and it said that 2MPAing was in misref, and it's still in misref. Yeah, we're done with it, but nothing to support. There was clear support for adoption on the list for stamp option TLV. There was a discussion about some changes that were requested. Will these be addressed in the IETF IPPM-00? Greg, are you here? Or is someone else who is a author of that document here? Okay, so we will note, we will note that we as chairs would prefer to see the resolution of that discussion in the 00 rev of that. So let that be minuted. Did we get note takers for this?
Yes, we do.
We do. Okay, excellent. And Jabber scribes and everything. Perfect. So IOM. I think we've done some really, really good work on this. So Frank, when did this come in? This was a little over a year ago, right?
Well, it came in a little like 2 years ago.
2 years ago. That's over a year ago.
You've taken all the steam away from my presentation, right?
Yeah.
So,
sorry. Oh, do you want me to skip the slide?
I'll go through the timeline.
Okay, perfect. I think personally, and also as chair, this was a good idea. I think we got a really good, this is what sort of cross-area contribution in the IETF and cross-area review in the IETF is supposed to look like. I mean, this came from a somewhat different community came in here. We got, good feedback, good discussion. There are a few other sort of like options to add on here. The data model draft is basically done. Then, as we discussed a lot at our meeting in Prague, the next set of documents, a lot of them focus on encapsulation headers. The question that I want to ask from the chair is, so bringing IOEM into IPPM got a lot of sort of measurement focused and transport focused eyes on it, and I think this was a very good thing. Is this room the right place to get the right eyes on the in-caps drafts? So with respect to the IPv6 destination option, I think the answer is yes. We have had good cooperation with the 6-man working group, which is, so we do the work here and there's review in 6-man in the past for measurement related destination options headers. So let's do that again. For the other ones, I think we really do opinion, and I want to open the discussion up a little bit to see if there are other opinions on this. That for each of these documents, we need to make sure that the right people are in the room to understand the nuances of whether this encapsulation is the way that it should be. And there are people in line. Tom
Herbert. So I'm a little concerned with the broadness of these encapsulations.
Okay.
So we know about the IPv6,
yep.
And that makes sense. I am a little worried that this is going to try to cover every possible encapsulation, including some UDP encapsulations, where it's questionable whether or not you can even do that per the spec.
Yeah.
I assume SRv6. So what is the scope of these encapsulations? Are we trying to? So
there's the set of documents.
Requirement, or is there some scoping of it?
There's the set of documents that have been written. So that's when I say these encapsulations, I mean the documents that exist. And so there was some discussion, for example, on an IPv4 option, which is, I don't think that's going to happen. Let's put it that way. That's the non-pejorative way to say that, is I don't think that's going to happen. There was discussion about an ether type or about using a next header field. There's all of these. So the encapsulation we're talking about.
There's discussions on so many things. Maybe pare it down and say what is the priority. So I think it's clear for IPv6, maybe for IPv4, that would be a separate discussion. But how do you determine where the work is if it's everywhere?
Right. So what I'm hearing is at least feedback in this room that we think there might be too many of them and we need to focus on a few. Is that a good paraphrase?
What was the last word?
And we might need to focus on a few.
Focus on a few.
A subset of them.
I like
the ones that we are.
We can expand in the future.
Yeah, exactly.
But focus on the few. I do like the fact that the data model is completely separate from this. So the assumption is you should be able to take that and apply it to different places, and that's a common model. We leverage a lot from that. So that's a good sign.
Hello, Frank.
A little bit more perspective on the whole thing. So we did decouple model or the data fields from the encapsulation for that very purpose, to allow for different speeds on how the thing's getting put into one or the other carrier protocol. The whole thing is contribution driven, though, right? Yeah. So we can't really say you must work on this and then nobody works on this and it's our key priority. I think that's not useful to decide. So I think we have work going on in multiple working groups where there is a natural home for that particular encapsulation to happen. I think the best example was NSH. It was relatively straightforward. NSH got picked up in SFC.
So, yeah, what's the status of that draft right now?
Well, it's progressing. I think it needs one cleanup cycle, and it's probably going to go for a working group last fall there. So I think that's a good example. There is work on SR that happens in spring. There is work on MPLS that happens in MPLS. There is work on Geneve that kind of happens in NDO3 at the pace of NDO3. And but I still believe that it's useful, even though there is kind of peering working groups, that we need one place, because otherwise you end up with re-explaining the case to these other working groups, especially if they're fresh and new to IUM as a technology, despite the fact I think that we've done the shopping tour so many times. So if we can keep a handle and have kind of a home for the things that, well, are IUM related in IPPM, and then go for peer reviews with the various working groups in case they are not really focused and willing to go and pick certain things up, then I'd much welcome that. And that is also a way where you can go and then inspire your level of priority by people coming to a common place instead of you need to go and shepherd, well, which is pretty much headless chicken, like Germans call it, or herding cats, like in English. I like the headless chicken thing. Just imagine the picture. But I think then it's much harder to go herd the cats if you don't even have a common place where all the cats come at a time.
Can I ask a question? How many more cats do we have to herd? I mean, so V6 is here.
Can we fast forward maybe and then table that discussion?
Because
I have a list
okay, cool.
of things
We'll talk about it when it. Yep.
So that we can have a discussion on a document by document basis.
Yeah.
I do think that we only have to answer a question around 2 things. So maybe it's less of a hard question than we think.
Okay, good.
Yeah, me a living area director. I just want to add one point because like every working group has a charter and some of the working groups are chartered to do their own extension and they don't allow other working groups to do extensions. So we have to like look what's in their charter as well, not only what's in this charter. Individual note on what something you said, I think this going around and explaining it every time to all the people over and over again, that's actually a positive thing because you explain it to those people who wants to use it, right? Who are working on this protocol and they need to understand it, so you have to do it anyway.
Good point. I think the comment was more towards stuff that doesn't have a natural home. So certain things don't have a natural home, like this either type thing. It's hard to go and find the right place for it. If you have the right place for something, then, well, I think we've all, with the exception of 6man maybe, we had all the people pick it up that thought like, yeah, here's the home. So I think the problem doesn't really exist where we have a real working group that is focused on the extensions. I think it's more the problem where we don't have a working group that is a natural home.
So I would submit that with the ether type specifically, the right people to make the determination about how to do that are definitely not in this room. However, let me make a suggestion and see if this works. For future, for present encapsulations where we don't know where there's a home and future encapsulations that people might be interested in, I think IPPM is a place to discuss those and dispatch them out to the place they need to go. Okay, so let's do that.
And so, of course, we'll want to hear, more in your talk, Frank. But I think that one of the proposals I was going to make that we can think on while we're listening to all of this is, definitely have a slot in IPPM in which we kind of get the update of the status of all the encapsulations. But I think we've definitely seen load in lightning talks or in other talks of individual presentations for given encapsulations for which I think the content, we don't have the experts in the room to really know whether or not this is the right direction. So I think having updates of summaries of how these are all progressing, how we can dispatch, how we can help is very productive, but we may want to consider, like when we get requests for a lightning talk of here's a new encapsulation, say this should instead be folded into the update of how we're expanding our encapsulations throughout the IETF.
All right, I think we are done with that one, so we will go on to liaison updates. Al. Oh, liaison roundups, sorry. Does this work?
It does work.
Woo!
Didn't hit myself in the head with it. That's what Hello, everybody. Hello, everybody. Hello, everybody. So I'm trying to make this as exciting as possible. That's for sure. So let's just jump ahead. That's a picture from the Calgary Stampede. So here's the progress to harmonize on a metric of IP layer capacity, really on the maximum IP layer capacity. At ITUT Study Group 12, we have sort of moved their end-to-end performance and specification, recommendation Y1540, down the approval line with about 39, I guess it's about 39 new pages, something like that. The lab and field testing is complete. Field tests with many different access types confirm the lab results that we've been doing for about a year now. So we still got some speed bumps, comments to resolve, but we're on the way to do that. So in the ETSI Technical Committee on Speech and Multimedia Transmission Quality, STQ, they are telling us that they've approved their revised technical specification on high-speed internet KPIs. And so that one's a done deal for maximum IP layer capacity. That's going to help us get those other comments resolved, in fact. So that's a good thing. I'm not really working in BBF, but I've had some informal discussions, as I mentioned here at the bottom. But they sent us a liaison here in IPPM on their quality of experience delivered, basically 3 items that are of interest to folks here who measure performance. QED, the application performance, that layer performance, that's done. And of course, they've got IP layer performance testing. It's based on STAMP, and Greg Mirsky is working with them diligently there. So the informal discussions I've had, kindly set up by Dave Sinecrope, I've encouraged taking up the work on IP layer capacity, and I'm going to fly around Europe in September trying to get that started. So we'll see how that goes. And so let's see, we have the opportunity to discuss and possibly join the harmonization this week. It seems like we've got about three and a half, maybe, let's say 3.5 legs of a 4-legged table in harmonizing on IP layer capacity. And a planned side meeting this week to discuss both the draft and the liaison reply. So that's it. I've rounded it all up. Oh,
yeah.
you can't read the
Draft
link.
Morton IPPM capacity.
Capacity.
Yeah. Why does it say that?
It's because it started out to be a draft where we helped trivia people learn about capital cities.
Okay.
The real story is my keyboard misses characters, and Al didn't see it.
Is that a typo in the link, or is that a typo in the name of the?
It's a typo in the draft. And now I don't have to cover this during my draft time.
Great.
I'm going to put up another 00 where capacity is spelled correctly, and then I'll go to work on the Cap City one, which helps the trivia people.
Okay, excellent. Thank you.
Thank you too.
Questions for Al on this? Going once, going twice. Next up, we have Al Martin.
Okay.
On ARA.
Thank you. So no update to the draft, but lots of good comments. Thank you, Frank Bachner's. Let's go. Let's see. We got some terminology problems. The terminology for nodes in the path was defined in our framework RFC. Host is a computer capable of IP communications. It includes routers. That's not bad, but wait. A router is a host that facilitates network layer communication between hosts and forwarding packets. And now it sounds like a router is something special in the middle. Then 8200, which is the BIS of the original V6 document, says a host is not a router, but but the definition is not path specific. So we got some context thing going on here. And in the mail I sent to Frank as a result of our discussions in the hallway, Vince Cerf used to describe a router as a PC with a graduate student wrapped around it. Thank you to Vint for giving me a chance to get a laugh. There's a lot of commonality there with our host definition. So in any case, let's look at this. Today, nodes in the path can be a coherent compute environment, so virtualized within the computer. All right. So we got some options. I put them on the list. Feel free to jump all over that. For option A, retain host, add a new node term and definition. So we, keep 2330 as is. A node is any network function on the path capable of IP layer communication. It includes the 2330 hosts. On the other hand, we could revise host and use the word node in a general way. A node on the path possessing a coherent compute environment and capable of IP layer communication. It also includes RFC 2330 hosts. And option C is the one you suggest on the list, or now really quickly and creatively at the mic. Any preferences for these? A, B, or keep looking, Al? C.
Frank Bruckner's. I think the easy fix that I also proposed in the email is let's move from host to node and see that we at least can align with, well, what 8200 says and the more modern understanding.
Yeah.
And then you can say, well, the node can be virtual and physical, like just invent some new nomenclature. And at some point, I think we need to do a 2330 bis, clean that up. I didn't really, and I asked around quite a bit before writing that email. I didn't find a terminology document for the IETF. I think that's the bigger problem, where things like node, host, router are really clearly defined and what they do and what they don't do. But otherwise, I think some of the 8200 six-man mess that happened from a discussion perspective is irrelevant if you just refer to 2330. That's what I found. It's kind of cool.
Yep.
Yeah.
So I was getting ready to say, the more you talk, the more work you're volunteering to do. So stay up there.
Sarah.
Okay, there's a comment on the Jabber from Ignacio who says, for me, B is good.
For what? Oh, B is good.
B is good.
B is good. Okay. Okay.
For myself, can you go back to the previous slide?
Yep.
As somebody who is supposed to care about the RC series as a whole, I have a problem because if you have 2330, oh, I'm sorry, Sarah Banks, poor line, oops.
Yeah.
2330 says one thing, 8200 says another. Now go to your next slide. So resolving it this way, to me, you have a problem because if you're suggesting to redefine it and then go back through every RC that has host in it,
No.
I'd be surprised if that's what you were suggesting. So if you're not going to do that, then I think an easy option is to, if you're going to use host, then define what you mean as host for your draft, or go with Frank's suggestion of use a node.
Yeah. Yeah. I kind of think node is clean, and I really cringed when I read the word computer there in this day and age. It didn't bother me 1998, but it does now.
So it sounds like C is drop host, say node.
Yeah. Okay. All right. Someone please drop that in the minutes, and we'll think about C. Very good. Let's see. I'm probably out of time, right?
You got like 2 more minutes.
2 more minutes. Cool. Okay. So let's see. Yeah, we have to do some work here to align the traceroute style methods with the hybrid methods. The hybrid methods are much more reliable ways in that almost everything is a cooperating host in the tracing path. With the traceroute, that's not always the case. So we'll seek ways to align this. I kind of think that there's some qualification of the statements in the section, like the one I've quoted here. They need to be qualified to, this is traceroute only kind of problem, something like that. And then 5338 is our XML expression of traceroute output, basically route output. And would be good to at least get all the requirements for an update. I agree with that, Frank. It would be better if we had an updated data model as an IETF Yang model. That's even more wonderful. Show of hands of who would like to work on that. Okay, so we're going to make that definitely different from the path that this draft is on. We'll assemble the requirements the best we can, and hopefully others will put that together at some future time. Maybe even these authors when they can find a minute. So the next steps are the working group weighs in on these key questions. We gotta leave some time for the list on A, B, C, and that includes the at questions in the text. They're easy to find. There's some more areas for development there, and Footer today. Footer gave me his comments. I've read them, Footer. I've got the response conjured in my mind. There's things we can do there. I like that you jumped right on this and actually did more work this morning after we talked. That was great. I appreciate it. Thanks so much. So both the reviewers from last time checked in and actually did the reviews. Reminders help, folks. This is what I've learned. I'm hoping for a working group last call on this by 1:06. And co-authors, if you're out there, please help Al. Please help Al do the stuff that has been proposed here. Thank you very much. Any other questions?
Thank you. Other questions? Good. So this seems to be progressing well. So yeah, hopefully we'll be done with this in Singapore.
Singapore. That's where we're going next.
Yep.
Yes, that's right. Good. Thank you.
All right. Multi-point alt mark.
just gonna
Giuseppe.
hand this off.
Okay.
Bingo.
Here's the.
Hello, everybody. This is an update about the multi-point altmark draft. We are at 0.2 version. This is just a recap about what are the motivation for this work. We started from the base RFC 8321 that presented the point that is valid for point-to-point flows. And there is only one limitation, that if it works for point-to-point flows or multicast flows, we have to select the 5 identification fields. But we want to introduce a methodology that can be more general. So we want to define the identification fields without any constraint. In this way, we can monitor, for example, an entire network or multi-point flows. So in this way, but we have to define a new approach for the measurement. The multi-point network can be split into a cluster partition, and cluster partition can be combined in different ways. And this allows a more flexible and intelligent, we can say, performance measurement. The draft details also the algorithm for this cluster partition. So we call, as I say, intelligent performance management approach because we call the network zooming. In general, a controller can calibrate and manage the performance measurement. It can start without examining in depth our network. But so in the beginning, we can monitor just the full network from the ingress to the egress points. And in case of problems, so if we experimented some packet loss or the delay is too high, we can reconfigure the network, we can configure the clusters, and we can make a more detailed analysis. And we can act in 2 ways, or we can change the traffic filters, or we can activate new measurement points within our networks. This is just an example for packet loss. So at the beginning, we can activate the counters only at the edge. So the number of ingress packets and numbers of egress packets is equal. So packet loss is 0. The delay is less than SLA values. So everything is okay. We don't need to activate measurement points in the middle. It's okay. If we have some packet loss in our network, we have to deepen our analysis. We can configure the cluster partitions. For example, in these networks, if we apply the algorithm that we have also described during the last meetings, we can find 4 clusters with 4 colors. And if we analyze and if we calculate the packet loss for each cluster, we see that for the red one, we can experiment the packet loss. So we can focus the analysis for the red clusters. And in that case, we apply more specific traffic filter to understand the path that is experimented the loss. So in this case, and so we are able to identify the fault. So this is just an example on how do you apply this intelligent approach. So in general, it's a complete performance measurement framework. So this can be applied not only for packet loss, so we can calculate not only packet loss per cluster basis or per combination of clusters, but also the delay measurement apply to this kind of measurement. But for the delay measurement, we have 2 different ways to act. The first one is about the multi-point path basis measurement. In this case, we can calculate the mean delay that is representative of a multi-point path or of our clusters. Okay, we can argue if that mean delay can be useful or not, but there is also the second way that is for single packet basis measurement. In this case, we cannot use the double marking as in the base RFC 8321, but we can use the hashing approach. But the hashing approach, some of us can know that has some problems, because if you have to identify the hashing values, the hashing samples can have some difficulties. But if you can help the correlations in terms of space with the topological point of view by using the clusters, and in terms of time by using the alternate marking that creates the block of packets, we can easily make a correlation between the samples also in a multi-point environment. So that's why we say it is a complete framework. So we analyze all the alternatives we have to measure packet loss, to measure delay for multi-point path, for single packet analysis. So what are the change from the 0.1 version? We make some consideration about the overall architecture, because we do need to have a centralized management to do this intelligent approach. And we added also some use cases, for example, SD1. The path selection can be done also by analyzing the cluster behaviors, and this can help also traffic visualization and topology mapping. Okay, I think the next steps in the opinion of the authors, the document content is quite stable. So we can value if we can consider the path for RFC. So that's all.
There's a question on Jabber from Ignacio. How are the clusters found? The draft only presents an example, but to do that in a distributed fashion is not trivial at all! Exclamation point.
No, there is the algorithms, and unfortunately I don't have the slides, but there are several algorithms. In fact, unfortunately, there is a paper that will be published in this year, probably in September, and that will details additional methodologies to find the cluster partition. In the draft, we define also the simple algorithms that we can identify the subnetworks in the net. So the basic algorithm means that we have to identify the cluster and the group of nodes where the packet loss property is still valid. The packet loss property means that the numbers of packets ingoing is equal to the numbers of packets outgoing of the group. So that is the basic way. And there are different algorithms to implement this partition.
He says it should be added later than things.
Yeah. I will add, of course, the reference to the paper, but it's not public for now. So, but in the next revision, I will do, of course. It's in the plan. But,
okay, so here you say beginning the path to become RFC. Can you talk a little bit more about what you mean there? So it sounds like you've got feedback that there's some missing detail that will come in the next rev. Are there other things that you expect to put into the document before we could go for a working group last call?
I think the reference to this paper will be important.
Yep.
To give.
When does that get published?
In an IEEE networking.
Yeah. When?
In September.
Okay.
There are
Yeah.
some
All right.
should happen in September.
Yeah.
October.
So yeah, 2023. Yeah, no, not that bad. Okay, so that's the
Probably we
gating
can add
function.
the reference and.
Yeah, no,
this-
right. You want it to be published before you add the reference to it, because even as an informative reference, if it's an informative reference to a thing nobody can get to, that's not useful.
Okay.
Good. Okay, so we'll bring this back, I guess, quickly next time, and then talk again about moving it forward. Excellent.
Okay.
Justin.
Good afternoon, everyone. So as you may already know, my talk will focus on the implementation of IOM for IPv6 inside the Linux kernel. So how does it look like? Well, the very first design goal was obviously to have zero allocation during packet processing. So everything needed for IOM is allocated at node registration. So, for instance, we allocate IOM namespaces data and everything related, extension headers to be encapsulated with IOM headers inside it, and much more. We also took advantage of the current parsing of extension headers of the kernel by improving it and adding some useful info that would allow us to ease and fasten the decapsulation process. For that, we store, for instance, the total padding size of an extension header And during IOM parsing, we also store offsets and size of each IOM blocks. So each IOM option to be removed, obviously. And at the bottom of the slide, you can see a graphical representation of the data structure we've used to represent an extension header. So here it's generic. It can either be a up by up or a destination option. And this one is stored at each IOM interface, which must encapsulate IOM headers. And you can also see some data offsets in red. And actually, when a node encapsulates IOM headers, it also needs to insert its IOM data. And that's a way for the node to remember what option is and where it needs to insert the data corresponding to that option. So what we got from measurements, well, those are still early results, but we can already learn a lot from them. At the top, we can see the topology we have used for measurements. And actually for measurements that I will show you, we have just used a portion of this topology. So forget about what's outside the cloud. So just focus on what's inside the IOM domain. And the reason for that is that we wanted to be compliant with the RFC 8200, which says that you cannot in-flight insert or remove extension headers. So this way, we generate and encapsulate traffic, IOM traffic, inside the IOM domain on the same node. At the bottom, so for the left graph, you can see a comparison between throughputs measured for 3 cases. The first one is for a vanilla kernel, so without touching anything. The second one is for a batch kernel with IOM. So this is just a batch that is compiled, but totally passive. And the last one is for a batch kernel with IOM, this time with nodes that are registered. So this is really the last one that is interesting, and we can compare the first one with the last one. And actually, you can see a small drop of around 7%. And this is not that huge, especially when you know that this may not be the most realistic case. Indeed, in this case, we insert IOM headers into any packets we see. So by definition of IOM, I think, so that's my point, I think that you should not insert IOM headers at any packet. So that's why I wanted to measure another thing, the impact of percentage of insertion. And you can see on the bottom right graph that between 0 and 20% of insertion, you have still quite good performance. Then it starts dropping until 50%, and then it remains stable until 100%. So by seeing that, my advice to any operators that would implement this and configure this, my advice would be to limit the percentage of insertion to at maximum 20%. I think I'm gonna skip this one because I think I'm gonna run out of time. So this one is really important. I wanted to have a discussion with all of you. And the first hot topic is actually the opaque state snapshot option. We had a lot of discussion with Frank and Shweta and also with Tom during the hackathon. And I think we all agree on the fact that something needs to be changed on that option. Its status is quite unclear, especially when you are in a pre-allocated context, because all it does is actually break the idea of pre-allocation. So I get the whole point of this option, but I think there needs some discussion and improvement to end up with something really good. The second one is more, I just wanted your opinion on that. Would you see some interest of having the incremental trace mode enabled inside the kernel? Because my point is, I don't really think that will be good, because this is not a performance solution at all in the kernel. And I don't think that operators would use it by knowing that. And so yeah, I just wanted your opinion on that. And the last one is about the new version that we will just merge on the repository, which will be totally compliant with the RFC. And one of the solutions was to use IPv6 tunnel encapsulation. But this solution also brings a lot of, let's call them some small issues. And the first one is that you may have a leak of IOM data. So let's think about a scenario when you have overlapping tunnels. And for instance, I'm a node and I'm configured to decapsulate IOM namespace 2, for instance. But this namespace is also encapsulated in other ones. So it is in an inner header and I cannot see that. So I will just let it go. And this is almost the same idea for the second point. The scenario is with nested tunnels. So again, I'm a node and I'm configured to insert my data if I see the IOM namespace 2. And again, I can't see it because it's inside. So I will not insert my data, I just forward it. So someone told me that for the second point, it's totally fair because tunnels are actually like that. So you could just ignore what's inside. And I tend to agree because it's easier for me and it makes our life easier. But I think you should take into account that operators may want to configure such a configuration, have such a configuration, and they still wanted to have each node insert their data. So I think, again, there is room for discussion on that point. And the last one, actually, when you encapsulate IOM headers, well, you have to know what the destination is. So right now, this is a static configuration, but it would be nice to have something based on the routing. So I was thinking at first as something like a signaling protocol like LDP or something like that, but I think there are certainly exist other easier solutions without reinventing the wheel. So I'll be happy to share on the mailing list or here or whatever on those important points. Thank you. You can find the code as a patch for the kernel on this repo, and feel free to drop me an email if you have any question.
Tal Mizrahi, thanks for this. Can you go back a couple of slides? This one.
This one?
So how come there's almost no difference between 50% and 100%?
Well, actually, yeah, it's a bit surprising, but we have no real explanation because actually what's the difference between the two? It's you insert 1/2 packets and the other you insert in every packet. So I guess the difference is not that big.
Should be a pretty big difference.
Yeah, I know.
Two, right?
Yeah.
So it's kind of surprising. So what was the total overhead that you inserted for packets? The total number of bytes that were...
You mean in terms of delays or?
No, the increase in the packet length.
Yeah?
The length of the pre-allocated...
Okay, so maybe you're talking about those. I kept it for as a backup. So when you increase the trace, actually the kernel will reallocate some space. So that's why you see some drop during the process.
So what was the length? How many bytes did you add for each packet?
Actually, the common base case was a single IOM namespace with a single trace option. And from that, we increased the number of trace options inside a single namespace, or we increased the number of namespace.
How many data fields?
It depends on the use case.
Is there a more detailed document that describes it?
Yeah, you can find it on the repository, and there is a paper related to that. So, yeah, more details. Or on the mailing list, you can send me an email. No problem.
Okay. And regarding the question you asked about the incremental trace option, in my opinion, it is very useful.
For the incremental, you mean? Yeah.
Yes.
Yeah.
So quite a few of the switches and routers out there that implement IOM have an easier time doing this using the incremental trace option.
Okay, thank you.
It is useful, in my opinion.
Thank you.
We're cutting the line after Tom.
Doing that work. Also, on Tal's earlier point, I would second that incremental is useful. for the very reason if you really have IOM started on the host and then really connect to a fabric that does incremental, maybe you don't want to go into that mode where you're mixing incremental and pre-allocated in the very same packet, which is what otherwise probably do. So I do believe that there is a use for doing incremental in the host, despite the fact that, well, if you just have forwarding hosts that are all software and all kernel-based, well, you can argue whether that's useful. But I think the mixture, the hybrid basis is useful. The other point on kind of blaming opaque, we've done all that for a while. I think there is a way to go and at least contain the problem. And containing the problem might be using the profile idea that Tal came up with at 104 in Prague, where you say, well, if I know that my nodes are not inputting random data, but I can go and predefine that, then I can do the length calculations up front. So loads of the variety that you can dream of doesn't really happen in reality if you go profiles. And a final ask for you to comment on. So you did that for the 512 kernel. What's your plan? Could you shed some light on what you're going to go do with getting that into master and upstream?
Yeah, definitely. So we plan to have a patch for newer versions and try to make it go upstream. Yeah.
Tom Herbert. So I looked a little bit at the code. It's on the right track, and I definitely think that with enough cleanup, it could be
Sorry, lines are cut.
upstreamable. But one point, we do need an option number in order to get upstream. This is the same problem that PathMTU is seeing in IETF6-man. There is something called early IANN allocation that might be applicable here. It's probably more appropriate for the authors of the draft, but that might be something to consider to get this actually into deployment.
Okay, fine. Thank you.
All right, thank you very much. Frank, can you come on up?
I think we go use this one here.
Yeah, okay. That's the requirement.
Okay, so given it as an update, I thought about kind of doing the story that you were about to do earlier on. We started the journey apparently really 3 years ago, and I think together we came quite a long way. So it's the fine print, but that's the schedule that the quote-unquote data draft went through. So we started in Berlin in IETF 96, and we became, after doing the shopping tour across multiple working groups, including Ops AWG and whatever, even the discussion whether we need a working group for the work, we finally arrived, and I think that's also thanks to the white knight, like I call her, our dear ID, Miria, who came up with a suggestion that landed in IPPM, and I think that was a really good idea. So we landed in IPPM, and we've been progressing since then, and we've been having regular updates. So the whole thing went through a journey. I think it got significantly richer, wider, broader, better over the course of the last 2 years. And I don't want to go and cite everything, but I think if anybody wants to go and reuse the story, I created a slide for you.
So 104 was in Prague, but otherwise I love that graphic. I was like, hey, you went to Bangkok twice. Awesome.
Copy and paste is not my friend. I'm sorry. Could you fix that? It's a Google Doc. Well, we just changed the location. Anyway, so where are we at a very high level? Kind of what is the ecosystem looking like? And I'm sorry if not every single draft is up there, but I think those were the ones that kind of got discussed quite a bit. From a data fields perspective and the flag stuff, let's table that for a minute. We'll discuss that in detail. We had a recent mailing list discussion on immediate export postcard. I think we have a good resolution for that, which means get rid of the flag that we have for immediate export and write a new draft that is dedicated for postcard / immediate export that just defines that one new option to go and handle that case. So we just need to see the document, like future reference, but I think there is at least resolution on the way forward and what we want to go do with this one. Then we've been seeing quite a bit of kind of background work. The document's been progressing. We've not seen a lot of discussion around it, but we have a Yang document for IOM. It's there for a while, and it's also been updated and kind of fixes been worked into that. So maybe I think at some point, maybe now, we should go and ask the question, do we want to go and adopt it? Tal's work, I mentioned that at the mic earlier on, around the profile work, I think is a little early. I think it needs more maturing, so I think we can go and probably have a couple of iterations there. We had the discussion around data export earlier on in OPS-AWG, and I think the conclusion was that there wasn't one, but that people want more peer reviews on the document and then decide whether we really want to go and land it in OPS-AWG or here, or, and that's what Ignas brought up as an option, is as an AD-sponsored document, so that it doesn't even need working group adoption for that specific case. So that's another thing, but the baseline is more peer review because, well, it hasn't had enough reviews so far. I think that was the conclusion from the discussion so far. So that was a forward reference from the meeting that we had 104 in Bangkok, right? In Prague, but where we discussed like OPS-AWG should go and take a look whether they want to pick it up. The conclusion was go and read the document and send mail to the list, which brings me to the area that we touched on earlier on, which is this encapsulation laundry list. We talked to 6-man post the last IPPM meeting. The feedback was good and saying, well, go and progress it and come back frequently and give us an update on where you are. But we're happy that you do the work because we had precedents earlier on that it worked out well, that kind of cooperation. And Brian mentioned that earlier on between 6-man and IPPM. Skipping the next one for a bit of a minute, NSH, SFC Working Group, Genève, NVO3, segment routing's been presented, if we're lucky, in spring, and also in 6-man, I think. MPLS, I think, is progressing in MPLS. VXLAN GPE doesn't have a home in IETF, so we'll probably go and publish that as an individual RFC at some point once stable, which brings us back to the question that I'm always asked. And that question that I'm always asked that doesn't really have a good answer, and you mentioned that earlier on, is what do we do with V4? V4 options, well, we kind of tested the water. People didn't like it, including you. And I understand why.
It's not that I dislike it.
Sorry.
I'm telling you that other people will
Sorry.
I mean, I do dislike it.
The other people that we don't know, and there is restrictions that are pretty hard around that, which means like the space constraints that you have with options may render it only niche-y for certain cases. There is work to go and solve the problem a completely different way. Tom mentioned, not here, but earlier on in other venues, the work on putting extension headers into V4. Yeah, might solve our problem, but we need something for V4. And the best current thing is a kludge, which means you slap on 8 unnecessary bytes so that you can slap on the IOM header, which is the either type encapsulation that would also go and cater for other protocols like Genève. So that's an option. We can go there. Plus, well, the discussion that we had is we can only get an either type if ISG asks through a liaison to IEEE for an either type. And that requires that we have a working group adopted document that asks for that either type. So there is a little bit of a runway ahead of us. And the question is, do we want to go and take that effort? I've not seen too many lovers of GRE, but, well, it's the best acceptable option that I know of that is somewhat fitting into IETF overall general rules. The other option would be to go and see what else we can go do about v4. And well, that's extension headers for v4. We can ask for an IOM protocol type to go, IP protocol type to go and just, well, have one size fits all. Probably harder than either type. So I think we need ideas, and maybe here at the mic, but also maybe broader on the list on how to solve the v4 question in a somewhat reasonable way. Let me pause here. Tom.
Tom Herbert. So before we get to that question, I do want to point out that Geneve and VXLAN are UDP encapsulations, correct? So the idea is we're going to go into UDP payload and do the IOM? Or is it something outside? Okay,
it's outside. So it's not. So it's within the VX. So with VXLAN, we chain that in with either type, or in Geneve, you chain that in with either type, or you use the Geneve capability to carry TLV. So those options exist, right? So you can do it natively in Geneve if you want to.
Okay. So the problem is RFC 7605 defines what a port number means. And if you're identifying in the network Geneve, and you're changing UDP payload, it's unfortunately a bad thing. So
yeah, we know that.
Those, so this is what we saw at Spud, right? We had the exact same things. We had to come up with this crazy magic number. So I'm not sure if that's what these are intended. Those may not be feasible in the long run. And then, so yes, I did mention the IPv4 extension headers. That is plausible. If the choice was between that and creating a new IP protocol number, I would say use the existing one. I think that's actually going to be a lower bar. And I'm a little confused about the ether type, but what's that? This would be hop by hop option. So we would put an IPv4 hop by hop option.
Yeah, Duke, Brian Trammell as an individual, surprisingly saying do that. That seems like the right thing to do. Yeah, so actually I came up here to say, like, so the problem here is that what you want is the lowest overhead way to wedge an IOAM header into a v4 packet for things that are going to be underneath it in v4, correct?
Yeah. And a path that is quote unquote workable in the IETF. That's very important.
And your trade-off is between number of bytes on the wire and number of years in working group meetings. Right.
Yeah.
So I hate to say this, but I think that the thing that's there is GRE.
Sorry,
right?
say it.
So GRE and v4 is, I mean, like, so I was thinking, what is the easiest way to get a thing that's ether type identified in v4 and it's GRE, right?
Yeah, but it's the most hated option that we have, right? It's
right.
But because it's the only one.
Right. But you already, like, the difficulty of doing this with a new protocol number is that you're not going to get a protocol number because nobody believes in them anymore. And there aren't that many of them, right? Like, so they are both useless and rare, therefore you can't have one. But we already have one for the hop by hop options header that is undefined in v4 space. I don't necessarily want, like, you can take that to 6-man. I won't. But
why 6-man?
Or Tom can.
The 6-man work on v4 extensions.
Yeah, exactly. I mean,
right.
So you're going to do this anyway, right? Stuff using v6 extension headers in v4. Yeah, do that.
We got to get extension headers working.
Tom will do the work for you. I mean,
yeah, and he'll
just
put,
for clarification,
he'll put the
where
code
is
into the kernel, right? So that's the thing.
It makes sense for IPv6. That's a given, right? IPv4, if there's enough traction. So I did post the IPv4 extension headers, and it was quite interesting to see the feedback. Primary concern is, oh, we're improving IPv4. And I thought we were sunsetting it. And yet some of the operators came back and said, I still have customers in IPv4, so we have to keep improving it. So it may be less of a technical question and more kind of a quasi-technical thing, in which case I would need help with that.
And Tom, just for information, where are you doing the work on this? Because I wasn't clear from the document which group were you doing
The
this in.
IPv4 extension headers?
Yeah.
It was a one-off draft. I posted it to 6-man. I was kind of hoping that they could take that, but it's not really IPv6.
Right.
So the next question, and the problem is there's no form man. So
Right.
there was really no obvious home for it.
Mhm.
And so I didn't pursue it too much. It did come out of discussions related to IPPM, honestly, because of the IPv4 issue.
But if this is what we're suggesting to kind of tie together to this solution, we would need to know like where is that going to be worked on?
Probably not here.
Yeah, because I don't think it would be here.
Not here.
Well, and so the GRE actually had the convolution. I'm assuming this is GRE with the new ether type that's contained.
Yeah, right.
Yep.
Okay.
Yeah.
So that's not really GRE then. We're actually doing
Yeah,
one
it's- yeah,
protocol
correct.
over another.
You use GRE to put a new ether type. That's
To your point, Brian, about worrying about the number of bytes, I think the bigger problem is just finding something that actually works with IPv4.
Yeah, so basically the GRE was using GRE to abuse the GRE header to wedge an ether type into an IPv4 header in the same way that we are abusing the protocol number for a hop-by-hop header to wedge an v6 extension header into v4. It's the same kind of abuse.
It's actually
But yes, but your design is a hell of a lot cleaner than the GRE design.
Yeah.
Yeah.
By the way, I'm going to cut the line on this one, and as a time check, we have like 4 or 5 minutes left to discuss this.
and I still have the update to the drafts. Yeah.
Yeah, so let's try to make these quick.
I've been away for a couple of years. I'm Matt Mathis. I've been away for a couple of years, and so I'm missing a little bit of context. Are you aware of an old protocol called IPMP? It died on the vine, probably in this working group, probably about 15 years ago.
So I'm not even aware of it. So
And it died on partially in a process error because it accidentally forked, and then the two communities couldn't agree. IPMP resembled this in many ways, but one of the things that they did that was kind of a hack, I'll say it's extremely was a hack, is they used magic numbers in the payload so the hardware could find the measurement object. And the rule was that the measurement object had to have a 0 checksum, so you could have the measurement object had its own offset checksum. And the hardware guy said, yeah, they could do this in chips, no problem. You can put a measurement object inside. The application has to know that the data isn't real, but you can do measurements then with streams that mimic arbitrary other applications. Find the cookie, the nonce, the whatever it is, update it on the fly going through the hardware, correct the checksum at the end, and send it on. It's a hack. However, nobody can detect that you're doing the measurement necessarily. I mean, you can do it in stealthy ways and so on. It has a bunch of advantages.
Just to point out, we also have a work on IPv6 encapsulation for IOM. It is also listed in the agenda, the last one. And basically, if we want to put the IOM data in the hop-by-hop options header, and there may be a risk, especially for the incremental tracing mode. So the data may become very large. So there is a risk to push the routing header out of the parsing window on the chip. So our proposal is to separate the instruction part and the data part, and to place the data part after the routing header in another maybe IPv6 metadata. Yeah, just to add.
Robin from Huawei, I want to propose one suggestion. I think you know that the IOM time is very precious. I hope that later we can confine our discussion on the encapsulation because it's too much time. We think we can focus on the IOM header itself. Because if we talk like this one, I know that MPRs also several the options on the IOM header and also maybe the GRE and also the UDP handle like this one. So if I think make our cannot focus on our work. I think that it's better we can take more time for the IOM header itself. So then we can maybe have independent session to discuss.
Line is cut. We cut the line, Jack.
As I see excitement to change IPv4 from the chairs, maybe we should reconsider the options. This is the only backward compatible solution as far as I can see.
I wish you luck in getting that past the ISG. I'll bet against it, but I'll wish you luck.
Okay. All right. So I think, as I said, like it needs to be something that is workable within the bounds of the IETF or in the realm. Let me go and progress to the two documents that are, I think, core and center, and that's kind of the core document that we started the journey on 3 years ago, and that IPPM is working on since 2 years. If you look at the key updates, we've done a little bit of editorial cleanup, and we've done text specific to the flags, where we really had that was the only piece of discussion that we had in Prague, that, well, flags were not everybody was comfortable with what the flags are and how they're used and the likes, and we've seen even on immediate export that we already came to a new conclusion and a resolution for that, that we moved that out and found that stuff out into a dedicated document. Why? Because we wanted to go and separate the stuff that is in discussion from the stuff that is really stable, so that we can really settle the stuff that is really stable, which is the data raft. So there's a couple of typos that I fixed, and I've done in that update. One clarification, Tal actually did the patch. One clarification on how namespaces are used, because there was some confusion that we got from the discussion that said, well, some people interpreted that from discussions that I had with people implementing the thing, like if I use namespace 1, I have to go and follow the document. If I use a different namespace number, I can do whatever I want. That wasn't the idea of a namespace. The namespace idea was that it gives you more context to the fields that we have defined. And that's what we're saying now, right? So I think that makes obvious sense, but just making sure that it's not misinterpreted. The other thing is the document split. So all the sections that touched flags have been farmed out to Tal's new document. So whenever something flags was discussed, so flags that are real flags like active, immediate export, and then loopback, they were farmed out. From a document perspective, excluding the flags now, well, there weren't really updates, and it's relatively stable, and there has been very few additional proposals. I think the last real big debate on the whole data fields document was the introduction of namespace, and that's kind of now many moons ago. So from my perspective, and I think multiple people voiced the very same opinion, it's ready for working group last call, and maybe we can go and hum on that if that's okay. But there was a question earlier on.
Basically, it's okay, and I do have a suggestion on the data field itself.
On the flags or the data fields?
The data fields.
Okay.
Yeah, I captured this at my lunchtime. I just find that there's a checksum complement field in the data field. I think data field is used to indicate that the data need to be shipped out to the controller or collector. So it's kind of confuse people to there's the last bit is used to indicate the existence of checksum complement. So I'm not to say this is not useful. I just say maybe we need to use another bit, for example, in the flag to indicate there's a checksum complement in this header.
So you want a second indication that the checksum complement is there?
Yeah, I think checksum complement should be in flag or other place, but not in the data fields. Because I think the data fields is to indicate what kind of data need to be captured and finally shipped out to the collector.
Okay. Maybe you can go and send an email to the list on that one, so that we can get started on the list. So I think the argument is not really node data, but it's kind of operational data to help the overall thing work, and hence you want to go and use it in a slightly different way than the operational data. Okay. I think it's a different type of data that we insert, given that it's just to help operations. Sorry,
Just,
Tel. I think
regarding
Tel
the-
was
yeah.
the one who brought that option in a while back.
Yeah, regarding that same thing, at this point, we define the flags as a separate field, which in terms of the timeline may be defined later than actually publishing the data draft. So we want to separate any functionality which is related to actually parsing the field from the flags, which different thing. So I think at this point, it's pretty clear that the bitmap is used for specifying which fields are in the option. And that's why, in my opinion, it's more convenient to have the checksum complement indication in the bitmap at this point.
Tom Herbert, so I have a couple comments that we've learned at Hackathon. I'll take these on the list, and probably not a lot of in-depth discussion right now. One, the opaque data is somewhat awkward in that you have a variable length field right in the middle of this bit field, so we probably would think about restructuring that. Another interesting thing was for some of the fields, there's both like a short field and a wide field. What happens if both of those are set? So it kind of gets this interesting dilemma. So you could actually have both fields present for like an identifier. What would that mean and how to resolve that? But probably a more interesting issue, the number of bits is limited. I think there were 24 and about half of them are used. What happens when we run out of bits? Is there a plan, that's extensible?
We'll cross that bridge when we come to it.
That bridge will cross you when it comes to it.
Well, it's a fair point, right? So
There is a solution,
anything
just
is
make sure
limited.
you don't allocate the last bit.
Correct.
Yeah.
No.
Yeah.
I think you need the last bit to then go and extend, right? Sure. That's the bridge that once we come to it. I think it's not really a current problem.
Go ahead and put a sign.
Yeah. No, I think that we can, at least I think we need to go and address that, maybe even in the document, as your earlier comment. So if you can take that as feedback from the hackathon onto the list, that'll be super helpful. Jay.
Jay Kumar, Broadcom. So Frank, I talked to you about the trace vector. Today it is a bit vector where the bit is representing the data type. What's your thought on making it as a bit mask on a namespace? Do you think that's a good idea?
So the question on whether we use a bit vector or a number, I think has been discussed multiple times. There is benefits and downsides to the whole thing. I think a couple of moons back, we settled on that people wanted the bit vector mainly for the reason that and you see that I think so far we are struggling to define what TEL has with the profiles. We are struggling to understand which combinations are actually meaningful from real world deployments. So what I would say is let's go with the bit vector for now until we have more operational experience, and then we can revisit that maybe in a version 2 of IOEM and see, well, those are the typical combinations that we need, and then we can encode them in a more compact way. Right now, I don't know whether anybody would feel like, especially in the IETF, as an authoritative source to say, those are the combinations that people will need, and those are the ones that they can't use. And I think that's the big problem right now with choosing, which is why a couple of moons ago, we arrived at, well, let's stay with a bit field. And I don't really think that revisiting things that we've done so far, especially on the current revision, makes too much sense. It's just like extending a runway, and I'm not sure whether we would arrive at a different conclusion, given that we have too many operational insights. I'm very happy that we see more and more implementations popping up now, thanks to Justin, for instance. But yeah, well, once we have the insight, let's go and revisit it.
Okay, but do we have a provision how to extend it? Like, let's say if we create a bit mask in the current draft.
In the current one, well, we currently go with the bit field. I think that's the solution at hand that we have right
So
now.
it's going to be a new header type, you're saying?
Well, or carve out some space that is left for a number.
Okay.
think we can go and think of something hybrid, right? So
Okay,
there is
just-
bits left that we can go and repurpose for a profile reference, for instance, whatever you want to go and use there.
Right. The reason I'm bringing it up is that in the current deployments, I already see that problem. The data types are so varied depending on the customer that creating a common profile is just next to possible. And given that we have limited bits, the enumeration of all the data types, that's just not possible. I just wanted to bring it to you.
Yeah, well, I think the escape path is opaque snapshot, but that's not a great escape path because that's kind of free format for everybody and hard to parse. So yeah, good point. So can I 3 more minutes on flags? Or maybe can we hum?
Yeah, let's, this is important to get through.
Yeah,
We're
this is-
10 minutes over, but.
Yeah, this is important, but
Yeah.
we're cutting to lightning talk time. So if you're in the end of that, sorry. Right. With just with regard to this document, so I think the plan would be let's go through this feedback we have from the hackathon, and we'll expect another rev or at least a good thorough discussion on that.
No, we'll get another ref post
And then-
once we have these things in, and then maybe we can go and initiate something on the mailing list.
Let me ask a different question. So this was the first and second hackathon that we got input from.
Mm-hmm.
This is the second, yeah. Each one of these we get 1 or 2 things out of it. It sounds like to me.
Well, and hopefully I think there is plans for having another one in Singapore, right?
Yes. Do we want to hold off on initiating working group last call until we can incorporate the outcome of Singapore or not? Like it's a trade-off, right?
There's always been yet another one,
yes.
right? So
Yeah. Right. No, but I mean, like, so at some point you're at diminishing returns. Do you believe that we're at diminishing returns yet on the improvement that we can make to the specification through learning things at hackathons?
Hard question, right? So we got a shitload of comments from the last hackathon.
Yeah.
We got 3 good comments from this hackathon. At least that's what Tom voiced right now.
Okay.
I can't predict the future, right?
So I did notice that you put a slide up that said working group last call, and a whole bunch of people came up and had comments, right? Like, so a really good way to get people to say things is just to threaten a working group last call. This discussion on this has been sort of like long and ongoing enough that we haven't had to threaten a working group last call in order to get people to stand up and say things. Yeah, it's. Tom, do you have something on this point?
Tom Herbert. So I would point out, so this hackathon was really only one router implementation, one host implementation.
Right.
So not a lot of data points.
Right.
I would much prefer that we had a couple of router vendors with real implementation. It might be difficult bringing the actual implementation. But to your point, it's not just hackathon, right? What is the implementation experience? Is there any deployment experience? Do we have validation? My comments, they may be superficial, and it's always the case. Well, if we say maybe we should rearrange the field slightly, maybe not, depending if somebody's already deployed that.
Yeah, I've heard some.
I don't think the comments is.
Yeah. I've heard some. Maybe we should rearrange things, but I've also heard some feedback that's a little bit more substantial with respect to like sort of editorial stuff and things that were hard to figure out, right? Like, so we're not looking to change the implementations as much as we are looking to improve the specification, to improve the chances that it is easy to build an interoperable implementation only reading the spec before we send it to working group last call, right? Like that's the bar that I'm trying to set here.
So why not? So we'll get input from this meeting from hackathon. Sort it out on the list, and if it all gets sorted out, then proceed.
Then like so, and usually the way that these things sort of work out is that the last call button gets pushed so that the last call ends at the next meeting. If things go very, very quickly, then we can do it before then. But yeah, so it seems like a plan.
Let's get the comments on the list, and I'll try to go and get an update done in August timeframe, so that it's not like dragging. Okay. So the other document is the more active thing that we had in the last meeting was around flags. So the new draft is really the stuff that was not really feeling like completely settled by the group in Prague, and so all of that is in the flags draft now. It's really to go and split the conversation. So what is in there? It's 3 flags. It's the loopback flag, and the loopback flag existed from the very beginning. It's a flag to go and do what I would call efficient trace route. It's mentioned and referred to in Aura in Al's document, so that you can go and compare that to the classic methods like Paris trace route or even a really classic trace route, and what you can do with hybrid methods. Just tells you at every single hop, like go and send a copy back to the originator, and the originator has to be the encapsulating node of IOM. So there's a couple of constraints around there, so not to go wild on that. So you can go and detect the path in a single round trip. The second thing is the immediate export flag, and I mentioned that there's been active discussions on the list on that particular one around, well, not using that flag, but using an IOM option and borrowing text from the PBP draft, which has many things in there, including how you could go do things with IOM, and we have a dedicated document on that. And then, well, if you have an option, you don't need the flag anymore. And the third one is the active flag, which is a bit of a helper flag, I would call it. It's not active in the sense like, I want you to do something with this. It's active in the sense of 7799, where you say, well, this is traffic that is used for probing active measurements. So the UDP probe that you guys have done at the hackathon, including IOM, could have put the active flag on so that from an operational perspective, that traffic would have been easier to detect for whatever reason, right? So that idea was there, and we farmed that out in a particular document in order to have more debate. So, Greg, go shoot.
Loopback flag. Have you considered the impact of using a loopback flag in inter-domain scenario?
Sorry, say again, in which scenarios?
Inter-domain. You have multiple domains.
Good question. I don't think so, because IOM is a per domain feature per se.
It's per IOM domain.
Per IOM domain. And, well, multiple IOM domains together, not sure. So as I said, like, it's been built with a very specific use case, and Petter brought that to us, where he said, well, I have my UDP pinger, I want rapid detection. Can we do something by combining the UDP pinger with IOM? And well, we built that, and we built that as a prototype. We socialized that at Bits and Bytes and IETF, and then it kind of entered the draft. So that's how it worked. And it's been useful for those cases. We might need to go and massage it further in order to make it really applicable across the board.
Tom Herbert. So the loopback is a little deceptive to me, because when I think of loopback, I think it's one shot. But if every device is responding,
correct. Everybody sends you a copy.
What I was thinking. So, for instance, in the UDP ping with the probe, we sent it all the way to the destination. We want it to come back, and all the nodes filled out their information, and we just get one reply packet. Mm-hmm. So I'm wondering. So I think I posted about having that, and I called it reflection. But for the loopback, is there a real use case for this that's been identified?
Yeah. That was the work with Petter's draft on UDP ping probe or whatever. Because the thing is, like, if your probing doesn't make it to the very end, so you have probes configured in your data center all over on all the application ports, and then, well, you see a probe break-in. What do you do for that particular probe that broke? You're attaching IOM information to that. And that means if you do that from both sides bidirectionally, both of these probes will travel to the point where you have the broken device or the broken link. So you can, with one round trip from both ends, if you correlate that information, you can relatively rapidly figure out where things went wrong, faster than with classic trace route.
Right.
That was the use case.
So basically this is a glorified trace route where we do it all in one shot, and there's a use case for that. Yeah. Okay.
Kulevinder's individual, you designed a really nice amplification attack there.
Yeah, you could call it the amplification flag.
Tom Mizrahi. So that same comment was made on the previous IETF meeting, and we added a section about it to the current draft. It says, well, this is obviously a performance implication and also a security implication. So we added some discussion about it. Obviously, it exists, so people need to know about it, but it can't be prevented. It's very similar to traceroute.
It's a tool. It's a hammer. You can kill somebody with a hammer.
The point is not only that it has implications. The point is that it can be used by malicious attack. So you're creating a tool that to easily create the amplification attack. It's not that be careful what you do with your traffic. You're creating the tool that hackers will love because they will really flood your network using.
Well, if you allow the attacker to send you traffic with IOEM, yes. But, well, that's probably likely traffic from outside your domain, right? I'm not sure.
Well, how can you guarantee that it's outside the domain?
I'm going to jump in line for that, but.
So we'll be happy to get any comments about this specific new section, and then we can continue the discussion.
Okay, thank you.
Yeah, we can bike shed the names of the flags and how many blinky warnings they should have on them. I like calling it the amplification flag, actually. But you're the AD. You can just get up and start talking.
Yeah, sorry, because I was in the room for a little while in between. Is there now any open document where we don't know where to home it, or?
I'm going to take that question in a second. I'm going to handle this one, and then I'm going to go back to that. Okay, sorry. Yeah. All right. Good. So, adopt as working group document. I don't really think we need to go through the whole rigmarole of doing a 2-week call. I will make the following statement from the chair. We intend to adopt this as a working group document. We intend to give you an instruction to send us a IETF 00 revision of this in a week or two. And if anybody we'll announce that on the list. And if anybody has a problem with it, you should have a really good reason why you have a problem with it. We will consider really good reasons why you might have a problem with it.
So this one or this one without immediate export?
You're intending to remove immediate export and put it into the next rev of data, right?
I'm intending to. Well, there's going to be a new document on immediate export.
Yeah.
So just defines that particular option.
So this one without immediate export.
Data. Okay.
Yeah. Okay. So the instruction would be the next revision of this document, according to the plan of the authors, should be an IETF IPPM document. And if anybody has a problem with that, you can yell at the chairs and have a good reason. Because doing the whole it's content from a working group document, right?
Correct.
It's fine.
All right.
I have a question from the chair. Now I have another question from the chair before that. Does it make sense from a specification readability standpoint for the content in this document to be in a separate standards track RFC from the rest of the IOEM data model document? Like this was separated out to make the discussion easier. Do you want the text back in one doc or do you want 2 docs? That you don't have to answer now.
Well, I have an answer, right?
Excellent.
It was in one document.
Right.
It was in one document for a reason, because that's easier to digest, right? So that people don't have to go.
This way is easier to discuss.
Yeah.
Right. This is why it's separated out. Do you want to hold the publication of the data model to pull this back in after everything has?
As I said, I don't want to go and hold the publication of the data graph forever. If the model is like we get the 00 out on the flags, and then we can go and converge on that relatively quickly. Maybe we can go and fold it back in the time frame that the data draft kind of also comes into revision 07. I would be in favor of that, as opposed to having 2 documents. Yeah, because I think if you have everything in one place and you dump that on one person and you do it that way, and then he has all the references in one document, it's always better than having two documents. Can people also read two documents? Yes, absolutely.
Right, yeah.
So a
is like
slight
6
preference,
now,
but
so-
not a big one.
Okay. We can revisit that later. Now let us go back to your list of documents to verify. This is also an AD question. Are there any of these for which we do not have a plan moving forward?
I'm interrupted now as an individual question on the flex.
Oh, okay, go back.
Comment
Yeah.
on that again. So besides any security and application attack and whatever, so like I had some general concerns that if you use flags to instruct the intermediate router to do something specific, that's like beyond the scope of what you initially was intending to do, right? So that's like for me a completely different protocol. So I have the feeling there's a little bit more discussion needed.
Yeah, this is one of the reasons to separate it out. Because one of the outcomes might be is we adopt this as a working group document and it's like, we don't like it.
Yeah,
I mean, that's,
but like, that's like I would assume that it makes sense to move forward with the base data model because
Okay.
it's very clear.
Yeah. Excellent feedback. Cool. No, stay up there.
Like one point, if you keep because you said there's one of the other encapsulations that already is ready for working group last call. I don't think any encapsulation should be published before the data model is published. So there's a kind of entity.
Oh yeah, looking at the speed of what SFC is at right now, I'm not worried.
Well, so they won't. So I mean, just as a matter of how clusters work in the RFC editor process, they won't be published as RFCs because there's going to be a normative reference and it'll go in a misref state. It will be more difficult for the ISG to review because it's like, hey, encapsulate this thing. What thing? We're not going to tell you. But
Yeah, like we need that many bits, and then suddenly you need more bits.
yeah, right. Yeah, that is a bit of a risk. Exactly.
Okay.
Are there any documents here, especially in the encapsulations? Because I think everything else is fine. Are there any documents here in the encapsulations that it is not clear from the outcome of this meeting what the next step is?
Yeah.
Yes.
The Ethernet encap.
The ether type. And I think the outcome of the discussion was,
do we want it? And if we want it, where should we take it?
So not IPPM. That's a very clear outcome. Maria, do you know where we should send the ether type thing? Should get Suresh to AD sponsor it.
Yeah.
Yeah.
Actually, I wanted to say AD sponsor of somebody else, but not Suresh probably. Also, he owes me a favor, so maybe. So is somebody actively working on that?
Sorry?
Is somebody actively working on that?
Yeah.
Okay. Because the only concern that I always have with AD sponsored is that it gets often less review than other documents which have a home in a working group, right? So I have to look at the history and see, like, was it only presented in IPPM or was it discussed in any other working group so far?
No, I think we discussed that in NVL3 as well. So we've been doing a little bit of a shopping tour with that.
Okay.
And so it originated from the original GRE cap. Yeah. And then people said, you want an either type? If you want an either type, please go to IEEE only once, because it's very unlikely that you're getting more than one, because there's multiple protocols that would benefit from one, and that evolved to Brian writing who's now retired. He has shitloads of time, so so that we can go and take that forward.
It seems to me that, like, just as another discussion venue, if there are different people in the room in int area, that would be another place where you could get feedback on this.
Yeah, we can go and drive it to int area, but the likelihood that int area says, yeah, please.
Right. Yeah, but at least.
What I would like to do is I would like to figure out if I find an AD to AD sponsor that, and then that AD will figure out if we need to do anything else to get more review on the document.
Okay. Sounds good. Thank you.
Okay, so that's a plan for everything then. Excellent. Thank you. We are now 27 minutes beyond time. Yeah, okay. Yep. So, stamp extensions. Greg, take it away.
Okay, extensions to simple two-way active measurement protocol. Thank you to Rakesh and Tehran for comments, suggestions, and help to improve the document. Okay, so what extensions? We take what we refer as base stamp packet format. For the sender, it's well-known sequence number timestamp and 30 octets of padding to make it symmetrical, and then we append TLVs, and TLVs can be enclosed. Some extensions we consider the mandatory, optional, experimental, and vendor private use, so that to create appropriate IANA registry. Extirpating TLV to be able to create packets of different size. Location TLV, it was a very good discussion. So location TLV idea is that reflector copies from the received packet the source MAC address, source IP address, and destination IP address, destination port and source port, and sends it back to the sender. So the sender can monitor what is a penultimate router for the reflector. And that we get the contribution from Henrik, a Syrian, from their experience in using T-lump white in the field. So they find that it's a very useful feature. Again, it's not a testing, it's a monitoring. Timestamp TLV, well, because of the way how timestamp is obtained and what synchronization it used, it affects clearly the accuracy of the timestamp. And understanding the accuracy of the timestamp, we believe it's useful. So there is a timestamp for that, TLV for that. Class of service TLV. It's primarily for the case of backhaul, wireless backhaul, when their provider operator has multiple services on the same path, then the services are differentiated, and they use a different class of service. And traversing different domains, sometimes the services, these markings, class of service markings, has to be remapped. And because it's a very manual labor, sometimes humans do make errors, and their behavior that it exhibits itself, demonstrates itself, is that higher services packets get dropped while their low service, for example, 3G, keeps going. So the idea of this is that sender can request the reflector to return back DCP marking as what received. More so, it can instruct the reflector to use the specified DCP value for the reflected packet. So in this way, in a very short sequence of test packets, operator can verify how their mapping in the network, if it works properly, or if there is a misconfiguration. Direct measurement TLV, so it's pretty simple. The mechanism of stamp is to do synthetic loss measurement, but there is an interest in doing sometimes direct measurement, or basically collecting the counters of their certain flow of the file packets that are in profile of the flow. And definition of the in profile is up to their operator. This is a pretty standard. It's well known from 1731 or 6374. So the next step, we have some outstanding changes that we want to make based on our discussion with Rakesh. The question was that to change the naming of these fields either to ITU terminology 1731 or to 6374. So that would be good to have input from their working group, but it's more editorial. And as you know, we're, I don't know, are we still in an adoption poll, or we already closed adoption poll?
It is adopted.
It's adopted. Thank you. Okay, I appreciate all your feedback, support that helped us to go over this hump. Yes.
Rakesh from Cisco. Thanks for addressing the comments and all the feedbacks.
Sure.
There are a couple of comments. One is about this direct loss measurement TLV. And if we make it hardware efficient, if you can make it the first TLV right after DM message, then its location is known, and we know where the offset, and it's easy to implement in hardware.
Yes, yeah. And thank you for this comment, because what we intend to do further is to really go over each TLV and be more conservative and strict about how this should be utilized.
And the second comment was that in the base stem, there are 27 MBZ, plus there is a byte offset. So the issue was that if responder is stem and querier supports this TLV extension, but responder doesn't, and you get a message, the way I understood, the responder may get confused because it might think the 28 and 29 byte is supposed to tell you the size of the padding afterwards, and in this case it's 00, but then there is one more byte, so then it may not be able to process it. So I shared that comment on the list.
Okay, so in your scenario, the sender is TWAMP or sender is a stamp?
The sender is the stamp that supports the TLV, but the responder doesn't support because maybe the responder already implemented stamp.
Right, but in this case, the responder just will respond because their server octets are 0, so he can respond might be with a symmetric packet, but basically would not try to parse TLVs because he will look at them as a padding.
Yeah, so it's 00 plus, but 00 means there is no more padding. It should be 0, then there is 1 byte of padding. So I think
well, okay, I'll need to read. Yes, I saw your question. I need to read. If I have a question, I'll go the follow up. But the idea was that why we made this field must be zeroed so that it indicates that you don't have a server octets that you must copy.
Yeah, I think so. Typical use case, customer would have deployed stamp, and then now this TLV comes and somebody upgrades the node, and now it cannot talk to the responder because responder thinks that the octet is 0, but it's actually 1. So now there's confusion.
Okay, I'll need to look at this. Thank you.
Other comments? All right, thank you very much. Next up is Rakesh.
Good afternoon, everyone. My name is Rakesh Gandhi, and I'm presenting the draft on SRPM using TWAMP on behalf of the authors listed. So agenda is basically to have a look at requirements and scope, the probe query and response messages. There is a need for ECMP and next steps. So the requirements is to for the delay and loss measurement for segment routing for links and the end-to-end SR policies for both SRMPLS and SRv6 data planes. We're not using the control channel signaling. So eliminate signaling as well as state on the egress node. That's the spirit of SR. There is requirement for ECMP as well as support for direct mode loss measurement. The scope is using the TWAMP and user configured the UDP ports and both the authenticated and unauthenticated modes. So probe query messages are basically the messages defined in the 53, 57, the TWAMP messages. For delay, there is a UDP port is configured for the unauthenticated mode. And same way, there is another port for authenticated mode. So this is to make the hardware implementation easier. So there is a new LM message format defined. It's a fixed message, very similar to the DM message, has a fixed offsets for the counters. And another UDP port is configured to indicate that this is an LM message. For SRv6, there is a SRH header with end function OTP for the delay measurement, OP for LM. For SRMPLS, there is a label stack. For response messages, depending on if you're doing one-way measurement, two-way measurement, or loopback measurements, response is sent a bit differently. For two-way, the draft defines return path TLV using the mechanisms that Greg is extending. For ECMP, for SR policy, for IPv4, IPv6, 127.8 destination addresses being swept. For SRMPLS, it's entropy label, or SRv6, there is a flow label in SRS that we can use. Definitely, stamp message format can be used. It's very similar to TWAMP. There is different padding size, MBZ size, but that can be user configured. And definitely the TLV are also applicable. As a matter of fact, we are defining return path TLV for two-way measurement. So we welcome your comments and suggestions. We do have implementations for this, and we are requesting a Spring Working Group adoption for this work.
Just a quick question for Nokia. Is this in parallel with the RFC 6734 document for Spring, or does this replace that?
Yeah, so we have prioritized TWAMP over the 6374. Although both concepts are similar, you would use UDP port, say 1000 for the 6374 and 11,000 for TWAMP. But there is more interest from customers for TWAMP than 6374.
Okay. Is this also including the signaling that came in 6374 to say whether or not you wanted unidirectional or bidirectional? Because it looks like some of the TLVs in here look like 7876, RFC 70, the URO type stuff for the unidirectional measurements.
So for 6374, the return path is 7876. For TWAMP is basically the same TWAMP. So query could be OWAMP and the response could be TWAMP. So we're not using 7876 for this TWAMP-based SRPM.
Last question. Are you indicating in this anywhere whether you want a unidirectional response or bidirectional response?
Yeah, so that's the extension we are adding, that if it's a two-way measurement, then we are defining a TLV, return path TLV, so that we expect the responder to send the response back on this path.
Thank you.
So there's a request for adoption in Spring that happened this.
No, so we couldn't get slot for this in Spring this time, so we'll try next time.
Okay, I mean, you can also ask them to run an adoption call by email if you want to do it between now and Singapore, right?
Yes.
So one thing that I would ask as chair is that you keep us up to date, at least on the mailing list as that progresses through, and as that goes to working group last call in Spring, we should also do a working group last call here to make sure that none of the changes that happen in Spring would make it not work with TWAMP. I can't even imagine what that would be, but just given how this works and how the integration seems pretty clean, but we'd want to make sure that people had a chance to have a last look at it before it goes through in working group last call. So
yeah, definitely.
Otherwise, excellent. We wish you luck.
Yeah, thank you for the slot.
And thanks for coming over to give us a heads up on this. So postcard-based telemetry. One lightning talk.
I'm from Huawei. I would like to introduce the postcard-based telemetry. We discussed a lot in this working group about the passport-based telemetry. That is the IOM the existing IOM. And here, this draft is going to describe the postcard-based telemetry. We described a lot about the trade-offs, including the performance impact, the encapsulation and overhead, and security, and configuration, and correlation, and job location indication. We also described the postcard-based telemetry solutions and the implementation considerations. Basically, we introduced the two PBT mode. One is called the PBTM. That means we will configure the telemetry data in each node, and we will use marking bits in user packet to trigger the postcard the data export. And this is applied and implemented in the enhanced alternate marking draft, and Joseph will later describe this. And the other mode is called PBTI. In this mode, we will insert instruction into the user packet, and every node will read the instruction and capture data and ship out data directly to the collector. And IOM is now discussing on how to apply this mode. Here, we propose a PBTI as an IOM option. We discussed and agreed in the side meeting and mailing list to define a PBTI as an IOM option. And we closed the discussion on flow ID and sequence number by making them optional. And we also agreed on the following option header as the starting point. And we also do the hackathon and to implement this option in physical devices. Here's an extended discussion on actions to indicate how to use the data. This is also from a suggestion. This is also a suggestion from mailing list. And here's the initial proposal. We propose to allocate 5 bits from the flag for actions. And we propose these 4 bits right now, which are motivated from IFA and Rombonica's draft. And here, there's other related action described in the IPv6 OAM TLV draft, like the send telemetry packet and send ICMP. I think it should, in this architecture, it should not be an action, but it could be a new data type. And next step, we will spin out the new IOM option as a dedicated draft. And this draft, I think we have well discussed, and we ask for the working group adoption.
Giacomo,
thank you.
So on the flags, you're thinking of adding actions. Have you thought about adding fragmentation as well?
Sorry?
Fragmentation.
Fragmentation for the action?
As an action?
I don't think so, because right now the PBTI only contains a fixed length head field. So I'm not sure if there's a need for fragmentation.
But the flags are from the flag draft, right? IAM flags. The flags are coming from the IAM flags, or this is a separate?
Right now we think we will firstly in this draft we reuse the flags described in IOM draft.
Okay, so that's what I'm suggesting. If you want to change it, then do you think that
define some new flags? Yeah, we can consider this. Thank you.
Actually, wait a minute. No. Oh, sorry. I thought you had a question. Sorry. Okay. Yeah. So. Yeah, probably we're not going to get to you.
Well, but let's see how long this question takes. Yeah. So just with regards to moving forward with this, earlier we were mentioning that some of the content that's currently in flags, we're going to be taking out. And essentially, we've come to an acknowledgement that we're going to do some postcard approach type thing. So I got the impression earlier that we're going to have a new draft for doing that. Is that something that this draft will be merged with? What is the end goal for our postcard and flags story here? Maybe Frank, you want to comment, or how are we doing this?
So from my perspective, I think as what we need is a definition of the new IOM option that describes immediate export.
Right.
Right. And I think where we can go and borrow some of, especially like if you go, I think 2 slides back, that data format, we can go borrow that. And with the existing text from immediate export, we can go merge that into dedicated draft. And I think that will good. So what I see from this document's perspective, I think it was mostly like a requirements gathering exercise. Because it loaned from other documents or other protocols that are not even IETF-like. And so, well, I think it's done its job from my perspective.
Yeah. Okay. All right. Another comment?
Parag, I think to answer your question, I believe your comments before should apply to that as well. Like, if we took the flags out of the data, while we eventually, per the discussion before, would like to have one document,
yes,
I think this should be a good path for that as well. To take it out, have a document as the flags.
That's fine.
Eventually,
yes. As far as how we end up publishing things, that's fine. So, but what I would like to see is what we go forward for, what we want to adopt as work is one document on this approach, and ideally get the authors from both working together on that document. So I guess, are you guys okay with doing that? Does that make sense?
Actually, I did not understand, or maybe my intention is to firstly adopt this approach document, this document, and also we will spin out the IOM option part and spin out this, and we will work with Frank or and other people to work on that new draft.
Okay, so I guess it's a little unclear to me why we would necessarily need a separate approach document that's different from the instance of how we're going to be using that approach in IOM. Especially if that's the immediate way to...
This approach is to describe the postcard-based telemetry, and we described a lot, including the trade-offs, the different modes, and also it includes PPTM mode, which will be used by other drafts.
Right. Yeah, I think ideally we would want to see that text because folded into the thing that we're discussing as the PBTI draft, and if we eventually need to fold the other one in as well, that'd be great. But I think we do want to see collaboration here and a single draft as a guide, especially when we're looking at the process of how we do working group documents. Like, there's some overhead for that, so having like a consolidated way to focus on this together, not having like a document for the theory of it and the implementation would be great.
Does that make sense?
So I think your suggestion is to see how we further split this draft and how to.
Right. Essentially, the authors of this document and the authors of the flags and the IOM work essentially like work together on what will be proposed as the working group document to cover this together.
Yeah, I think to get to Kenran's question, I think there is an aspect that applies to IPPM, and that's the IOM aspect. There might be a broader thing on how you want to go and do the provisioning piece and go and tag certain packets for export, and also the requirements discussion that you have, and kind of because that's all kind of related to INT as opposed to what we're doing here. that might even go somewhere else, right? I don't really know about that one, but I'm pretty sure that we need one for IOM.
Yes, exactly.
I think that's I think the baseline that we should go, and then think.
And my point is or our point from the chair, it's a very hot mic, is that the document that we pull for IOAM, for IPPM, that we make the adoption call on should talk about the data model, it should talk about the mechanisms driving the data model, and should talk about the mechanisms for deriving measurement information from the data model. So there should be a single document that takes some of the stuff from the flag stuff that's coming out of the current one, and from this document, we don't care who the authors are, but we would like to see collaboration that would be proposed, like do a new 0 individual and then propose that for adoption as opposed to proposing this for adoption, the other for adoption, and then we'll mix them up later because it's just kind of messy. Okay. Thank you very much. We are now out of time. I apologize to all of the Lightning Talk people. Come see us in Singapore. As a note to the chairs for the minutes, the next time that Frank asks us for 20 minutes for IOAM, we will not believe him. That was our oversight. But I think we had excellent discussion today. We got through a lot of stuff. If you didn't have all the wonderful input from the working group, yeah, excellent.
And to those, if you have stuff that you wanted to share in your Lightning Talk, again, apologies that we couldn't get to you. Yes, please do send a note to the mailing list about what you're going to share. Share the link to your slides. They are all posted, so we don't want to lose that good content. Thank you.
Oh, yeah. Blue sheets. If you did not sign blue sheets, please do. Put your hands up or come up to the front. Come on up to the front for the blue sheets at this point. Thank you, Robin. Frank.
What do we do about the
Oh, we didn't do that yet. That's here. That's here. We didn't adopt it yet. Keep doing it forward. It'll happen here. It'll clearly happen. That makes sense. Yeah. Because it ties.